1.1 Arithmetic Series. Here's a review of some terms from earlier in this school year. Review of sequences. Arithmetic sequence. A sequence in which each term is equal to the previous term plus a constant. Now right here we have two formulas, a recursive and an explicit formula. Recursive formula, I have to know each value of u to the 1, u2, u3, all the way to un in order to find the next term in the sequence. Now with the explicit formula, I don't need to know all the terms in the sequence. I can look at one term individually. A series is the indicated sum of terms of a sequence. The sum of the first n terms in a sequence is represented by Sn. You can calculate Sn by adding the terms u1 to u2 plus u3 plus all the way up to un. The sum of any finite or limited number of terms is called a partial sum of the series. Sigma notation can be used to represent the partial sum, where we have sigma, and that's just n is the first value of n, all the way until your last value of n that you are looking at, added together with the formula that they give you. Let us take a look at this example. They give us u1 equals 7, and for there on out, un equals un minus 1 plus 2, where n is greater than or equal to 2. So if we're to write the first 7 terms of this, u1 is 7, u2 is 7 plus 1, u3 is 9 plus, u2 is 7 plus 2, which is 9, u3 is 9 plus 2, 11 plus 2, 13 plus 2, 17, and 19. And we just found u1 through u7. So now to find S3, that's the sum of 7 plus 9 plus 11, the sum of the first 3 terms in our sequence, which equals 27. Finding S5, that's 7 plus 9 plus 11 plus 13 plus 15, add together, 55. Sum of the first 5 terms in the sequence. Well, to find S7, we'd have to add up the first 7 terms in the sequence. We know the first 5 gives us that 55 plus 17 plus 19, and that equals 91. So we just found the sum of the first 3 terms, the first 5 terms, and the first 7 terms in this sequence. Now let us turn to our second example, when they give us u1 equal to 12, and then un is equal to un minus 1 minus 4, where n is greater than or equal to 2. So listing the first 6 terms, well, u1 is 12, u2 is going to be 12 minus 4, which is 8. Here on out, subtract 4 away from each term, so 4, 0, negative 4, and negative 8 will be the first 6 terms of this arithmetic sequence. Now, it's asking us to find the sum from n equals 1 to n equals 4 of un. So it's in sigma notation now. So that's just n equals 1 plus n equals 2 plus n equals 3 plus n equals 4. Add all that together and just 24. Now this is asking us to find the sum from when n equals 1 to n equals 6 of the first of the terms in the sequence. So we'd have just 12 plus 8 plus 4 plus 0 minus 4 minus 8, and that just equals 12. So the sum of the first 6 terms in the sequence is 12. The sum of the first 4 is 24. Now this might be a little new to us. So now we're taking the sum from when n equals 1 to 5 of our function here, n plus 7. So this equals when n equals 1 plus 7 plus when n equals 2 plus 7 plus when n equals 3 plus 7 plus when n equals 4 plus 7, finally adding on when n is equal to 5 plus 7. And if we add all these terms together, that would equal 50. Now our next sequence here is asking us to add all of our terms from when n equals 1 to n equals 3 in the function n squared minus 3. So, when n is equal to 1, 1 squared minus 3, we need to add on to that when n is equal to 2. So 2 squared minus 3, and finally add on when n is equal to 3, 3 squared minus 3. This would then be negative 2 plus 1 plus 6, and we'd find our answer to be 5. Now, here's another example. So now we're starting at n equals 0 to when n equals 4, the sum of n minus 5. So, when n equals 0, 0 minus 5, add that to when n equals 1 minus 5, plus when n equals 2, add on when n equals 3, and add when n equals 4. If we were to add all this together, it'd give us negative 15. And those are all of our examples from today's lesson.